Hi everyone. So since there isn't a class today, at least there isn't a class with me, I know that you're having the online class with Bozidar, but what I'm going to do is I'm just going to go through and do some worked examples from the problem class so that you can see the process of how to do them. I'm not going to do all of them, but I'm going to do a fair number of them, chosen randomly. I haven't actually looked at them yet, other than I've chosen 4 from question 1 that we'll do. But I haven't looked at them yet, and I've done that on purpose. So I purposefully haven't looked at them because I think it will be more useful for you to see my process, to see what I do and what I think when I first see a question, which things I write down, what facts I remember, how I think I'm going to solve it, and hopefully that will give you some pointers of how to go about solving them as well. So let's just get on with it. We're solving ordinary differential equations, so they're equations that have derivatives in them, and we're going to be solving them by a method of integration called separation of variables. And because these question 1 ones are basically all the same, I just decided I'd do A, B, D, and E. So let's jump straight in with A. We have y dy dx is equal to sine of x. And what I want is I want everything on this side, the side that has dy at the top, to be with y's in it, and everything at this side to only have x's in it. There we go. So the way I'm going to do that is I'm going to times by dx, which puts the dx on that side, in which I get y dy sine x dx, and then I can integrate. Now, just briefly, you might be wondering, can I just times by dx like that? And the answer is yes, I can. And the reason that I can is you will remember that the derivative is actually defined as the limit of the ratio of these two numbers, some step in y and some step in x. And this step in x is just a number. When you take the limit, it becomes infinitesimally small, but it's still just a number. So yes, we can times like that. So now I do this integration, which is very, very simple integration that I can do. I've got a half y squared plus some constant, let's call it c1. Sine integrates to minus cos x, and then there's another integration constant like so. I can always just move this constant over here, in which case I get a half y squared is equal to c2 minus c1 minus cos x, and then I can let this thing equal to c. I could then do a bit of rearranging if I wanted to, so I could times by 2 and then take the square root, in which case I would get y of x is equal to 2 lots of c minus cos x square rooted. And that would be the solution. The important point to note is that I actually only needed one constant c. So I didn't need to write down a constant for this integral. I only needed to write down a constant for this integral. So this one should have a c, and this one should not have a c. And it doesn't matter which one you do. This is just about saving time, making life a bit easier. So let's do b now. 1 on x dy dx, and then y squared minus 2. So 1 on x dy dx is equal to y squared, 1 on y squared minus 2. And I do the same thing. I want all the x's on the side that has dx on top and all the y's on the side that has dy on top. So I'm going to times by x dx, and I'm going to times by y squared minus 2, so that I get this, which I can integrate nice and easily. And that would be the answer. You don't have to do anything else. That is the answer. This can't be simplified any further, so we're done. I think I'd said, which one was C? So C looks easier than B. Well, in C we're going to get 1 over x minus 3 and 1 over y. We're integrating 1 over functions, reciprocal functions, which are just logarithms. So you know how to do that, so I wasn't going to do it. Instead I was going to do D, because it looks like it might be a little more complicated. It's equal to ln x. Same drill as before, all the x's on the side that has dx at the top and all the y's on the side that have dy on the top. So I'm going to be timesing by x cubed dx. So then I've got y squared dy is equal to x cubed ln x dx. And I can immediately drop my integral signs in there to get a third y cubed. I'll put my constant in on that side this time. And then this is going to be done, as you can see, I'm going to have to do this using by parts. So I'm going to get uv minus the integral of v du dx, and I need to choose my u and v functions appropriately. So I'm going to have a u equals, and then a du dx equals, a dv dx equals, and a v equals. Now, since we have a logarithm, a ln here, we have to make sure that we choose that well. So if you integrate 1 on x, you get the logarithm. If you differentiate the logarithm, you get 1 on x. You can't integrate the logarithm, but you can differentiate it. So that means u is going to be ln x, and if you differentiate, you get 1 on x, which means dv by dx is going to be x cubed. So if I integrate, I get x to the 4 on 4. So putting those in, I get a quarter x to the 4 ln x minus the integral of x to the 4 du by dx 1 on x dx. So this is just the integral of x cubed, which is a quarter x to the 4, as we saw before. So I can pull out a quarter. X to the 4, and I get ln x minus a quarter. I'll just fill in that extra line there. That felt a bit fast. So that's the first part that's already written down, minus a quarter. And then this integrates to a quarter x to the 4. And you can see I've pulled out this a quarter x to the 4 part. Okay, and then that would be our answer. We've got a third y cubed plus c is a quarter x to the 4 ln x minus a quarter. And we're done. Now let's do E. So there's nothing to be scared about because the variable has changed. It doesn't make any difference to what we're doing. So it's just r dr is equal to sine squared theta d theta. Drop in my integral signs, that's a half r squared plus a constant. I put the integral sign in the wrong place. Integral sign should be there. Is equal to the integral d theta sine squared theta. Now here's a trick for how to do the integral of sine squared theta. We're going to use sine squared theta plus cos squared theta is equal to 1. And we're going to use cos of A plus B is cos A cos B minus sine A sine B, which means that cos of 2 theta is equal to cos squared theta minus sine squared theta. But from the first equation, sine squared plus cos squared is equal to 1, I know that I can write cos squared theta is equal to 1 minus sine squared theta. So this cos 2 theta is actually 1 minus 2 sine squared theta, which I can rearrange for sine squared. Lovely. So the integral then on the left here is, it becomes a half d theta 1 minus cos 2 theta. And this is something that we can do. We get theta, and then cos integrates to sine, which means minus cos integrates to minus sine. I have a 2 in the argument, which means I need to divide by 2. And so that is the answer. I know I'm going through that kind of fast, but you're always able to stop and check it and do it yourself, kind of pause the video. It's more just that I don't want this to be a ridiculously long video, so I'm trying to get through things at a reasonable speed. So now let's look at question 2. Find the particular solution of the following differential equation. Okay, so we have the differential equation y on x dy dx is equal to y squared minus 1, x squared minus 1, when y is equal to 3 and x is equal to 2. Okay, so we need to find y of x. That's what we're trying to do. We're trying to find y of x. Cool. Same drill as before. We need the x's on the same side, that's dx on the top, and the y squared on the same, and all the y's on the same squared as the dy on top. So I'm going to times by x dx, and I'm going to divide by y squared. So I'm going to times by these, and then I'm going to divide by this. That means that I get y on y squared minus 1 dy is equal to x on x squared minus 1 dx. Drop in my integral signs. Wonderful. So let's do the right-hand side. I'm going to rewrite it slightly. You'll notice actually that the left and right-hand side are both identical to each other, except one is in y and the other is in x. And because they're identical to each other, except for the name of the variable, we only need to do it once. The answer is going to be the same for both of them. So we'll just do it for the right-hand side. I'm going to change that x squared minus 1 into something else. X squared minus 1, I know can be written as x plus 1, x minus 1. And this I can use partial fractions. So let's look at this bit. We have x plus 1, x minus 1, x is going to be equal to x on x, a on x plus 1 plus b on x minus 1. So that means I need a plus b to be equal to I feel like I have been foolish somewhere. Yes, I have. So I was just going too fast and made a mistake there. So that's completely me being silly. You'll remember that actually what we do is we have whatever we don't have on the bottom, we have on the top. Which means a lots of x minus 1 plus b lots of x plus 1 need to be equal to x. So we've got ax minus a plus bx plus b is equal to x. This means that a plus b must be equal to 1. That's coming from ax plus bx needs to be equal to x. So a plus b needs to be equal to 1. And since there's no number here, there's no just number, that means that minus a plus b needs to be equal to 0. And these I can solve. I can see that a needs to be equal to b from that right equation, which means this is 2a is equal to 1, or a is equal to a half. So this integral can be written as a half lots of I didn't need to write that down. Sorry, small mistake. There we go, now everything's fine. At a half, lots of 1 on x plus 1 plus 1 on x minus 1, which is a half ln x plus 1 plus ln x minus 1. Very nice. Is equal to a half ln x plus 1 x minus 1. And then we are done. Great. Well, almost done. So that was one side. That was one side. So I'll stick in constant plus c. Doing the other side, that means I'm going to get half ln y plus 1 y minus 1 is equal to half ln x plus 1 x minus 1 plus c. So all that's left for me to do is to find this c, which I can do by using these values when y is 3 and x is 2. So first of all, I can just cancel this 2, these halves, which means this becomes a 2c, and then I can call that something else. I'll call it d. So I had when y is equal to 3 and x is equal to 2. So I've got ln of 3 plus 1 is 4, and then 3 minus 1 is 2. So ln of 4 times 2, that's 8, is equal to, so when x is 2, I get 2 plus 1 is 3. So that was, I'll just say that again. So here, 3 plus 1 is 4, 3 minus 1 is 2, so 4 times 2 is 8. And then I've got x is 2. So 2 plus 1 is 3, 2 minus 1 is 1, so that's 3, is equal to ln 3 plus d, which means d is ln 8 minus ln 3, which is ln 8 over 3. So the answer then would be that. Good. So what did we have in there that was a bit different? We had to use partial fractions, and then we had to substitute in the values to find this d, or c, or whatever you call the constant. And that's the key point. Whenever it says find the particular solution, that means find the constant of integration. That's all it means. So find the equation and find the constant. Very good. Nice. Let's do this one. 3. We have, so find the curve for which e to the minus x dy by dx is equal to 1 and passes through y is equal to minus 1, x is equal to 0. Okay. Same as before. Everything with x on the same side that has dx on the top, everything with y on the same side that has dy on the top. And I'm just going to rewrite it. This e to the minus x here, e to the minus x is the same as 1 on e to the x. So actually what I've got here is 1 on e to the x, dy by dx is equal to 1. So now I can times by e to the x dx, and I get dy is equal to e to the x dx. Can drop in my integral signs, and I get y is equal to e to the x just integrates to e to the x. So I just get e to the x, and then I have to remember my constant of integration. How do I find it? I find it using these values that I was given. So when y was minus 1, we had x be 0, which means c is equal to e to the 0 is 1, and then I subtract it, so I get minus 2, as in e to the 0 is equal to 1, and then I subtract 1 from both sides. So the answer then is y to the x is equal to e to the x minus 2. Nice and easy. 4. A curve passes through some points. Okay. How easy is this sketch to do? So x has 1 and a fifth, which means my y-axis is about there. Y goes from 2 to minus 10. So let's say this is 2, this is minus 10, this is 0, so this is y, x. And then our x values are at a fifth, and then about 5 times that is 1. Okay, so x is 1, y is 2, so that's the point 1, 2. And x is a fifth, y is minus 10, so that's about there. So these are our 2 points. A curve passes through the points, and its gradient, so the gradient m is proportional, but it's inversely proportional. So it's proportional to 1 on x squared, i.e. the gradient is equal to some constant, let's call it k, on x squared. And remember, the gradient is the derivative. Find the equation of the curve. The curve could be doing anything. I mean, who knows what it's doing as long as it passes through those points. So we have dy by dx is equal to k on x squared. Nice. If I times by dx, then I get dy is equal to k dx on x squared. I can drop in my integral signs and I get y is equal to k, the integral dx 1 on x squared. So let's do that. I increase the power by 1 and then divide by the power. So the power is currently minus 2. I've got the integral dx of x to the minus 2 here. So increase it by 1, it goes to minus 1. Divide by minus 1 is just the same as putting a minus sign in there. But then I've just got this 1 over x. Got to remember my constant. So I've got c minus k on x. You'll notice that I have 2 unknown constants, c and k, and that I was given 2 points. And as long as I have the same number of points as I do unknowns, I will be able to solve for my unknowns. So everything is fine. So I've got y is equal to c minus k on x. And what are my points? My points are 1, 2, and a fifth, and minus 10. So let's do this first point first. When y is equal to 2, x is equal to 1. So I get 2 is equal to c minus k. When y is equal to minus 10, x is equal to a fifth, so I get k over a fifth, which means I've got minus 10 is equal to c minus 5k. From this equation, on the first one, I have that c is equal to k plus 2, which means the second one becomes minus 10 is equal to k plus 2 minus 5k, which is minus 4k plus 2. I'm going to subtract 2 from both sides. So I've now got minus 12 is equal to minus 4k, and then divide by minus 4, I get k is equal to 3. And then since c is equal to k plus 2, that's equal to 3 plus 2 is equal to 5, which means my y of x is equal to c is equal to 5, k is equal to 3, there we go. And I can check that I got it right, because when x is equal to 1, y should be equal to 2. So let's check. Y of 1 is equal to 5, minus 3 on 1 is equal to 2. Nice. Nice, nice, nice. 5. Always reread the question when you finish it. Make sure that you've actually done what it said. Find the equation of the curve. Yes, we have. Good. We found the equation y of x, and we used the values that were given to us to find all of the different constants of integration and the constant of proportionality as well in this question that we needed to find. So that's very good. Now let's do 5. This is a wordy question, so I think it's really good that I'm going through this because is it wordy? Oh no, it's no more wordy than the last one, it just looks longer. So let's just do this one then. We have the differential equation y e to the y squared dy dx is equal to e to the 2x. Passes through this point here, a half 1. Okay, and we need to show that the curve that satisfies this differential equation also passes through the point 2, 2, and then sketch. All right, I'm going to times by my dx. I get y e to the y squared dy is equal to e to the 2x dx. Drop in my integral signs. If I look at this, I can see that if I differentiate e to the, that's not very clear, e to the y squared, I would get 2y e to the y squared. So if I put a half in front, this half kills this 2, I get y e to the y squared, which means the integral dy of y e to the y squared is in fact the integral dy of a half d by dy e to the y squared. These cancel, so that's just a half e to the y squared is equal to the integral dx e to the 2x. It's a half e to the 2x plus some constant c. Okay, so I've got a half e to the y squared is equal to a half e to the 2x plus c. Going to times by 2, and then I'm going to let 2c equal d. Just clearing that up, tidying that up a little bit. Then I'm going to take the logarithm of everything. The reason I'm going to do that is this is asking us to find the equation that satisfies this ODE. That means we need to find a y of x. And at the moment I've got exponentials, which I don't want, and I can get rid of those exponentials by taking the logarithm. So the logarithm of the exponential of y squared, ln e to the y squared, is equal to ln e to the 2x plus 2c. Okay, so this is y squared is equal to ln e to the 2x plus, 2c I'd call d, plus d. Which means y is equal to ln e to the 2x plus d square rooted. All right. Okay, so what was the point? The point was a half and 1. So x is equal to a half, y is equal to 1. Let's now find d. I've got 1 is equal to ln e to the a half times, e equal 2 to the times a half plus d, which we don't know, square rooted. So that's ln e to the 2 times a half is 1. So that's d plus the exponential, square rooted. I can now square everything. I get 1 is equal to ln d plus the exponential. I can take the exponential, and then if I subtract e from both sides, I find that d is equal to 0. Which means y of x, my function, is actually just ln e to the 2x square rooted, but the logarithm of the exponential means I just get 2x square rooted. So this is now my function. My function y of x is the square root of 2x. And what did it say? Show that the curve also passes through the point 2, 2. So let's check that. We want to have x equal 2, y equal 2. So y of x is equal to 2 would be equal to 2. X is 2. So that's the square root of 4, which is 2, which is what we wanted. So that's very good. And then it said to do a sketch. So let's do a sketch of the function y of x is equal to the square root of 2 of x. And we know that it passes through the points a half 1 and 2, 2. So this is y, this is x, this is 0. When x is a half, y is equal to 1. So there's a point. And when x is equal to 2, y is equal to 2. So here is another point. Y of x is equal to the square root of 2x. So y of 0 is equal to 0, which means this is a point. And we require that x be greater than or equal to 0, because if x is less than 0, then y becomes imaginary. And so our graph is going to look like that. Very nice. 6. Grain is pouring from a hopper. What is a hopper? I don't know what a hopper is. Sounds like it might be a cup or something. Grain is pouring from a hopper onto a barn floor where it forms a conical pile. Okay, so there's grain which is falling, and it's falling into a conical pile. So this is the picture that we have of height h, and it's increasing at a rate. What does a rate mean? That means that dh by dt, the rate at which it increases, is inversely proportional to h cubed. So we'll have our constant of proportionality k, and then h cubed. The initial height, so h at t is equal to 0, is equal to h0. Oh, okay. And the height doubles after a time t. That means that when the time is equal to t, the height has doubled, so it's become 2h0. Find in terms of that doubling time t, the time after which it has grown to 3h. All right. So what's the area of a cone? I think it's a third pi r cubed h, where this is r. Pi r squared h, sorry. That would be the volume of the cone. I don't need the volume of the cone. Don't know why I did that. So immediately I thought there, well, I should calculate the volume. I might need a surface area. No, I don't. I just need this information that it's given me here. So really what we're doing is we're going to find h of t, this function, and then we're going to set it equal to 3h0 to see at which t do we get 3h0. So we have, come on, there we go, dh by dt is k on h cubed. Same as before, we need all the h's on the same side that has dh on the top. So that's h cubed dh is equal to k dt. Drop in our integral signs. Okay, nice. This looks pretty much like our equation. That means that h of t is equal to 4kt plus, let 4c equal d, add d, and then raised to the 1/4 power. So that's our equation. That's our function h of t. And we know that when t is 0, h is equal to h naught. So h of t is 0 is equal to h0 is equal to 4 times k times 0 plus d to the 1/4. So that's just d to the 1/4, which means that d is h0 to the 4. So now I have h of t is 4kt plus h0 to the 4 to the 1/4. Nice. Very nice. I feel like I want to get rid of this k somehow. Do I know another point that it goes through? I knew that it went through 0, h0. And I also know it goes through t to h0. So that was from here, and then this is from here. So t and 2h0 is what I've got next. So h of t is equal to, my big T is equal to 4k big T plus h0 to the 4 to the 1/4 power is equal to 2h0. I can now say 4kt plus h0 to the 4 is equal to 2h0 to the 4 is equal to 2 to the 4, h0 to the 4. So 4kt is equal to subtracting this h0 onto this side. So that's equal to 2 to the 4 minus 1, h0 to the 4. This is 2 times 2 times 2 times 2. So 2 times 2 is 4, times 2 is 8, times 2 is 16, minus 1 is 15. So that's 15 h0 to the 4, which means k is equal to 15 over 4 h0 to the 4t, just by dividing by 4t from there, which means finally h of t is equal to 4 times 15 on 4, so the 4's cancel, is equal to 15 h0 to the 4 on t plus h0 to the 4/4, which can be simplified. I can pull out h0 to the 4, which to the 1/4 power is just h0, and then I get 15 to the t on t plus 1 to the 1/4 power. And that would be the equation. So this is where we do a double check. Did the question ask for anything else? It did. Find in terms of t, this is the doubling time, the time after which the height has grown to 3h0. All right, then, we can do that. We need for this thing here, we need for this whole thing, h of some t that we don't know. Needs to be equal to 3h0. That's what it wanted. We wanted to know at what time has it grown, has the cone grown to the height 3h0. That's what we need to know. All right, I can cancel off this h0 here, and then I'm going to take the 4th power. So I get 15 t on t plus 1 is equal to 3 to the 4. That's 3 times 3 times 3 times 3. Is 3 times 3 is 9, times 3 is 27, times 3 is 60, plus 3 times 7, 7, 14, 21, so that's 81. 3 times 3 is 9, times 3 is 27, 60, 7, 14, 21, 81, yeah, okay. So this is equal to 81, which means 15t on t, subtracting 1 from both sides, is equal to 80. I can then divide by 15. How many 15s go into 80? 6. So t over t is equal to 80 over 15 is equal to 6, which means that t is equal to 6t. So h, so what does this mean? This means that as a picture, if we go along in time here, this is 0, this is t, and this is 6t. This is h0, 2h0, 3h0. At time 0, our cone looks like this. And then some t later, it has doubled in height. And it's not until 6t later that it's actually tripled in height. Okay, I think that's all the questions. So I hope that was useful. I know that it was quite quick. Like I said, it's because I didn't want it to be a ridiculously long video. But you're able to pause the video, do it yourselves, check things. Feel free to email me if you have any questions or anything like that. I'm absolutely happy to help. Somebody did email me a couple of weeks ago and I never got back to you. I'm really sorry. I was in an incredibly busy week there where I'd gone on holiday and then I was ill on holiday. And then I forgot. So whoever that was, because I was covering a different class that week as well. So whoever that was, please, if you're still stuck, email me again. Otherwise, everyone, email me if you need me. I hope you're all okay. Missing you all and hope to see you soon.